Good morning, everyone. Welcome to this week's episode of Velodyne's new webinar series, Velodyne Lidar Live, where we'll be having conversations with experts from all areas of the mobility industry, talking about the ways this technology is transforming our lives and our communities in real time. I'm Pamela Gauchi, your host for the next 45 minutes or so, and joining me is my co-host Jane, who will be running slides in the background. And today, Velodyne's VP of Business Development, John Barad, will be talking to Asad Lesani from Bluecity Technology and Neel Dayal from Rogers Communications about the future of smart cities. First, a little bit of housekeeping before we begin. Let's take a quick look at our agenda so you know what to expect. We'll start off with a very brief overview on Velodyne Lidar, specifically looking at our UltraPuck sensor. Then I'll hand things over to John for a discussion with Asad and Neel, which will be about 35 minutes. And then we'll save the last few minutes for audience Q&A. So be sure to use the Q&A button at the bottom of your screen to ask questions anytime during the episode. As always, we are recording today's episode, which will be available to watch on Velodyne Lidar's YouTube channel. So let's begin. Here you see a few examples of Velodyne Lidar's suite of LiDAR sensors. Our product portfolio provides real-time perception data that can be used across a multitude of industries, including smart cities. Now, we're going to focus for a couple of minutes on Velodyne's UltraPuck, one of our surround view sensors. With 32 channels and a range of up to 200 meters, the UltraPuck generates approximately 1.2 million points per second in dual return mode. And since it's built on Velodyne's 558 patent, it provides a full 360-degree horizontal field of view to deliver accurate real-time 3D data. And add to that a compact footprint, low weight, and interference mitigation features. So what does all of that really mean? It means the UltraPuck can meet customer needs with highly accurate object detection and classification, both of which are critical for traffic analytics and pedestrian safety. And in this footage, you're seeing the high-density, long-range image generated by an UltraPuck on a drive through Nashville, Tennessee. Another notable feature, the Ultra's encapsulated package means it can handle harsh environmental conditions and weather. Additional features include pricing and lower power consumption, allowing for longer operational range and redundancy. And here you really get a sense for how detailed of a point cloud the Ultra can produce. So now I'd like to pass things over to Velodyne Lidar's Vice President of Business Development, John Barad. Hi, John.
Great, thanks. Hey, Pam, thanks so much. It's great to be here. I really appreciate it. And I'm excited for this conversation today because, you know, the potential that LiDAR holds, not just in autonomous vehicle applications, but a whole host of other applications, one of which I've been spending a lot of time on, both with Neel and Asad here, is looking at using LiDAR for traffic monitoring. And that's putting LiDAR in a fixed position, putting it on a pole so that it can monitor traffic in an intersection. And the benefits of LiDAR are quite vast in that, obviously, LiDAR is its own light source, so it works at night, which is when a majority of accidents and fatalities do occur. But also LiDAR works in all weather conditions. And one of the most important features that's becoming more and more of a hot topic that maybe we'll touch on a little bit today is that LiDAR can't really be used to detect or recognize people's faces. So built-in privacy is something that is being utilized in the sensor. From a utilizing LiDAR from an intelligent transportation system point of view to create smart cities and smart infrastructure, the benefits, you know, really what we're targeting are kind of threefold. I mean, we're looking at, you know, how do we reduce congestion? That's, I think, one of the key topics that smart city technology is looking to address. And in doing so, we also can have the opportunity to bring down pollution. So much pollution is caused by congested traffic, stop and go, and not only pollution, but even energy consumption with electric vehicles really coming online in a big way. And finally, most importantly, it's about safety. How can we protect all road users, not just people in vehicles, but because of the pandemic, more and more people are walking or using other forms of transportation. Just read an article that unfortunately out here where I am in San Francisco, there's been an uptick in pedestrian fatalities. So how can smart city technology, and especially the solutions that Bluecity and Rogers are putting together, help save lives? And so with that, we've got a great panel here with me today. I've got Neel, the Director of Innovation and Partnerships at Rogers Communications. Rogers is a Canadian communication and media company headquartered in Toronto, Ontario. They're one of the largest telecommunications operators in Canada with more than 10 million wireless subscribers. And Neel's working on a lot of really innovative projects. And also Asad Lesani, CEO of Bluecity Technology. Bluecity is a key partner of Velodyne's, and I've been working closely with Asad for a couple years now, and so he's become a good friend of mine. Bluecity builds an AI-powered multimodal traffic monitoring and data analytics platform, and it's gaining a lot of attention from state and local transportation agencies, and so I'm excited to have Asad here with us to tell us more. So before we get into kind of the little roundtable panel that we have, I thought it'd be great to give Neel and Asad a few minutes to introduce themselves a little bit more and their companies and tell us about what they're doing. And so why don't we start with Neel? And Neel, maybe you could spend some time and obviously tell us about your role in Rogers, but also, I think one of the key topics that our audience is interested in is really understanding 5G. I mean, we hear so much about it, and it'd be great to understand your perspective and what you're doing in this space, certainly as a leader in the industry.
Very good. Thanks for that introduction, John. And it really is a pleasure to be here today. I remember sort of my first introduction to Velodyne and Lidar technologies and Bluecity, and it was really eye-opening in terms of like all of a sudden the wheel starts spinning in your head on terms of all the possibilities. I'm really looking forward to talking a little bit about how we've brought an idea to fruition here with one of our collective objectives and initiatives. But yeah, I'm going to talk a little bit about 5G just to sort of level set in terms of what it is and sort of the value and the benefit that it brings. And then I think it'll become very obvious in terms of why there's such a great intersection between, the AI that Bluecity brings, the hardware and the Lidar technology that Velodyne brings, and then our network, which is, predominantly going to be built on top of 5G. So, just from a Rogers perspective, because I know not everybody knows Rogers, yes, we've got about 10 million subscribers here in Canada. But from a 5G perspective, we were the first to roll out 5G in Canada. Started in Vancouver, Toronto, Ottawa, and Montreal, but we've now since rolled it out to 170 different markets across Canada. So we have the largest footprint, and we were the first. We're also members of what we call the Global 5G Future Forum, where we collaborate with a number of other service providers, including Verizon in the US and Vodafone in Europe and Telstra, as an example, in Australia. So we're really, trying to not only be the first in terms of deploying the network, but positioning ourselves in a way that we can always be at the forefront of this technology, because we know that it's a generation. So maybe just to move to the next slide, we can talk a little bit about some of the features that I think are really kind of integral to what 5G is. And, not everybody has a full appreciation for each of the dimensions. We all hear about it. But there's sort of five key features that, are really going to make up the 5G networks of the future. And we're starting to see quite dramatic benefits, even in some of the early rollouts that we've had to date. So the first one that people tend to think about most is capacity. And that's really around, the bandwidth and the download speeds and the upload speeds that people are used to. And so here we're going to see, a real order of magnitude improvement. LTE, which is pretty good. And if anyone's watching from Canada, they'll know that the LTE networks in Canada are actually quite good. But, the theoretical limit of an LTE network is about 1 gig. With 5G, we hope to be able to get to that 10 gigabit limit that it promises. So definitely lots of capacity that will be available for all sorts of, heavy streaming type of applications. And I think, LiDAR would be an example of one of those types of applications. Responsiveness is another one, that's sort of the buzzword in the industry that gets used a lot is low latency. And that's really about being able to collect data quickly over the network and be able to do some decisioning and compute very quickly to be able to provide some type of an outcome and decision. And so that low latency requirement, if you think about an intersection, becomes really important, because how do you ensure that that vehicle and that pedestrian don't collide? You obviously are going to need some kind of low latency network if you're going to do any type of real-time communications in that environment. And so there we're talking about, eventually getting to a sub 10 millisecond type of latency, which is, quite dramatic in terms of even being able to process that as a human is very challenging. Density is another one. So again, another order of magnitude improvement. We'll go from 100,000 devices per site to up to 10,000 to up to 100,000. So that just means we can have a lot more sensors and cameras, etc., lidars, all dispersed within a particular area. And that just obviously opens up a whole world of possibilities. We've seen some of this happen in the past in Toronto, most recently, when 2.5 million spectators are there for the Raptors championship parade. Obviously that creates a bit of an issue in terms of what the load that it puts on our network, but we see again a real improvement in terms of being able to support these mobile devices and sensors on that network through the advances in 5G. Uniformity is a really important one that often gets forgotten. Oftentimes we hear the use case around robotic surgery, but even gaming as an example of one is you really want that consistent uniform experience across the network, so that you're not experiencing things like jitter, etc., that can cause a sort of a very fragmented experience. So we'll see obviously improvements from a uniformity perspective. And then finally, reliability. And I think that's the big one, is that now we can start to think about those mission critical apps that we weren't able to deploy over a network in the past. We're now able to use different sort of techniques and capabilities that are inherent in the 5G network to deliver that ultra reliable network that is so important in enabling a lot of these critical infrastructure and sort of smart city use cases. We'll go to the next slide. So yeah, this gives a bit of an example in terms of the evolution of 3G. I mean, I think we're all fairly familiar with this evolution, but the mobile web browsing was sort of the big thing, and email from a 3G perspective. From 4G, which is with the generation we're on right now, we see lots of benefit in terms of, finally using video, FaceTiming, et cetera, all of these sort of technologies. And we start to see the emergence of AR and VR as well as being, a use case that can sit on top of a 4G network. But 5G is, again, where we're going to start to see some of these real sort of critical industrial type of applications that were typically required some type of, wired solution. So things like the industrial automation in a factory floor, as an example. We're starting to see some work around drones and being able to manage airspaces. And obviously, the one that I think is important from a Velodyne perspective is the autonomous vehicle use case. And obviously, again, when you're starting to think about communications between the vehicle and the roadside infrastructure, you really are going to need to get down to that sub 5 millisecond type of latency. So those are some of the use cases in the real evolution. From a Rogers perspective, a lot of the work that we do has been, with different partners, mostly academic. I mentioned some of the other global telcos that we work with, and some of the incubators and some of the programs that are here in Canada that support 5G commercialization, like the Encore program. We're also, strategic partners with Ericsson from a 5G RAN and core perspective, and they've always been our sort of key go-to-market and technology partner from a 5G perspective. And obviously, we collaborated with Microsoft and some of the others as well, but specifically in some of the work that we've been doing with Bluecity, we were able to do a lot of the work with some of our colleagues there. All of that is underpinned by the Create Lab. And that Create Lab is really a way that Rogers is going to market in terms of co-creating solutions with the partner ecosystem. And we use a very sort of design thinking led approach to deploying, these new use cases. And so that's really kind of been at the core of our strategy, as well as it's not just great to have the right partners like the Velodynes and Bluecities of the world, but it's important to have the right sort of human-centric approach to creating those solutions with our customers. And so the Create Lab really underpins a lot of that. So in terms of research, just to give everyone a sense of where we're doing our research from a 5G perspective, smart cities, buildings, and infrastructure is a big one. And smart cities obviously is what we're going to be talking a little bit about today. But we also see applications that are very sort of interesting that can leverage things like Lidar technologies as well. And one of the projects is around natural asset management and being able to do different types of imaging to understand what's happening with our natural assets, primarily trees. And this is going to help us in things like understanding when we might be able to identify, potential for a wildfire, as an example. We've also been working on an intelligent transportation data platform with some of the work that we're doing at UBC. And again, we've had some really interesting use cases that we've been able to develop from the data sets that the Bluecity solution has been able to generate. And we can talk a little bit about that as well. Obviously, we're looking at drones. It's a really big use case, both from a spectral imaging perspective, but also from a delivery perspective. And so the network becomes very important in managing the airspace and the operations of these drones. And obviously, a low latency network becomes important. And then we're also continuing to do research around things like network slicing and how we can optimize the use of our network. And another really important concept, which is, multi-access edge computing. And what that really is about how can we take some of the compute that normally would sit at the edge with the device to within our network, but deliver, high performance compute at low latency. So thinking about moving the cloud much closer to the actual end solution and offloading some of the compute from the endpoint. And that's obviously something that 5G is going to enable over time. So those are sort of the key areas of research for us. As I mentioned, a big focus for us is in the intelligent transportation space, which is why we've been so ambitious in working with partners like Velodyne and Bluecity. And we think that there's just a lot of opportunities, not only in terms of improving, safety and improving accessibility for various groups, but also in traffic optimization in a way to improve that safety and then also to reduce greenhouse gases. And I think we all probably had a view into the improvements that we saw with our air quality early in the pandemic when we were absolutely locked down. And I think that as we come out of the pandemic now, as things start to open up, there's still going to be that continued focus on managing our greenhouse gas emissions. And I think that this type of intelligence becomes really important to help municipalities understand that activity. So finally, we'll just sort of talk about the project that we did last year, and then I'll hand it off to Asad. But last year we saw an opportunity to really kind of test these smart traffic solutions out in what I'll call the wild. And so we launched the first 5G smart city solution in Canada with the city of Kelowna. And what we did with Kelowna was we asked them if they could provide us some problem statements. And one of the problem statements they had was there was concerns around the safety in the downtown core around a few of the intersections. And so we partnered with Velodyne and Bluecity to deploy their traffic monitoring solution at the intersections in the downtown district. And we invited partners from UBC as well, the University of British Columbia. And we actually conducted a hackathon over the course of a weekend. And we identified not only some interesting core capabilities around traffic monitoring, but we were also able to identify some adjacent capabilities around things like collision detection and emergency response. And so, that was sort of a really interesting program, and it really was the catalyst for a longer term partnership that we're now into our second year with the city of Kelowna around in Bluecity, where we're continuing to evolve the capabilities and deploy new features. So I won't sort of go into that too much because I don't want to steal Asad's thunder. But this was really kind of a cool first 5G smart city project, and I'll say thanks to Asad and John for leaning in and making sure that we were successful on this one. And I think there's some really exciting stuff that's coming up soon that we'll be able to talk more about as well in terms of new features. Over to you, Asad.
Fantastic. Great. Well, that's great.
Great.
Thanks, Neel. Yeah, that's perfect. Right. Teed up perfectly for Asad to tell us a little bit about Bluecity, and I'd love to hear about, Asad, some of the use cases you're seeing and that you're working on both in Kelowna as well as more broadly in some of your other deployments too. So please take it away.
Sure, great. Thanks, John and Velodyne for setting up this webinar, and thanks, Neel, for the presentation. So yeah, I'm very excited about this event and our partnership with Velodyne and Rogers, and I really appreciate both sides trusting a startup company, and I think we have a mission that is aligned with improving the safety and road mobility and efficiency. So I just like to start with giving a little bit background about what is the problem that we are basically solving. So when it comes to improvement of the traffic, especially for traffic safety improvement, mobility, the backbone of most of the project is the traffic data. And the way that typically municipalities are collecting data is either using camera-based technologies, which is good, to collect data about pedestrians, cyclists, and all different type of road users. But the main challenge with the camera-based technologies is that the performance will be suffered by like low lighting condition, bad weather condition, which makes the solution unreliable for traffic operation that we need to have 24/7 data. On the other side, technologies based on radar, which are reliable to work in different weather and lighting condition. But the main challenge with radar-based technologies is that, first of all, we need typically 4 sensors to cover the whole intersection. And radar just mainly used for detecting and counting the cars without providing data about other type of road users. That's why, like in our company, we started working with LiDAR technology. It was very promising when we saw the initial performance back to 2017. So what we built is a real-time multimodal traffic monitoring solution that works in different weather and lighting condition. This enables us to use this solution for traffic operation application as a replacement for radar or inductive loop. At the same time, our solution can detect, classify, and track all type of road users, including pedestrians and cyclists, which is really key for running safety analysis, knowing how people are interactive, speed measurement, and those type of use cases. And in most of the cases, we get all this information with a single sensor at the corner of the intersection that reduces the cost of the installation and maintenance. And the solution that we build is already powered with 5G technology that enables us share the data in real time with connected vehicles. Those are more like use cases that we are working with university partners and Rogers as our 5G partner in Canada. And one of the interesting aspects that we see with respect to the using LiDAR in comparison with camera is how LiDAR can protect privacy of the road users. There's no way with LiDAR we can identify the face of the people or read the license plate. So that's a great value for LiDAR over camera-based solution. Let's see how it works. So when we install the LiDAR at the corner of the intersection, it generates real-time 3D image of the intersection emitting hundreds of thousands of laser beam every second, which allows us construct the 3D shape of the object within centimeter resolution. Each line that you see in this video demo represents a laser beam, and within each line, we have thousands of single points, each represent a distance measurement reported by LiDAR. And unlike a camera, LiDAR actively measures the distance, so that's why it really reliable to work in different weather and lighting condition. And also it helps to run the project without any calibration requirement, which is a really interesting aspect about this type of solutions. And then the way that the whole solution works is we install the LiDAR, we have an edge box that has a small computer on it, and then the LiDAR will be connected to our edge box, and then we run our perception software that reads frames of LiDAR cloud point data, then it detects the object, classifies them, and extract the trajectory of the road users. This is the core of our technology that happens in real time just at the intersection, so there's no need to have a high bandwidth network to transfer raw LiDAR data to do cloud computing. So then the extracted trajectory of the road users is passed to different layers of the application that I'm going to talk about a couple of those use cases that would build on top of our solution. So one of the main one is basically replacing using this technology as a replacement for loop detectors. So the user can can customize virtual loop detectors and then connect the sensor to the traffic controller, which potentially can be used to trigger traffic light timing based on the presence detection of the cars. But what makes the solution even more interesting, especially with respect to the safety, is the fact that you can extend those virtual loops for other type of road users, including pedestrians and cyclists. That means that traffic light controller can use this information to extend red light, for example, for cars, if needed, to make sure that pedestrians cross the intersection safely. And again, like there are other type of analysis that we extract from our technology, for example, measuring the speed of the object that will be accessed through our dashboard. It will be available to do more in-depth analysis on driver behavior, traffic light timing efficiency, effect of the weather and lighting condition, and also monitor overspeeding and potentially use it as a emergency dispatching or sending a signal to like police department if we see a high number of overspeeding for that intersection, specific intersection. One of the specific use case that I think there is a great value for in using this technology is running conflict analysis using our technology. Basically, the way it works, typically the safety of the intersection and other traffic facilities is most often assessed by tracking and analyzing police-reported motor vehicle crashes over time. But given the infrequent and random nature of crashes, this process is slow to reveal the needs of remediation. So an alternative solution is a proactive approach, and that's the approach that we're following with our technology in studying road user behavior, known as surrogate safety analysis. So the way that it works is our algorithm analyzes the trajectory of the road users in real time to measure post-encroachment time. PET is a factor that is used as a measure of conflict and is highly correlated to the risk of accident. And as we see in this demo, our algorithm identifies the conflict between those pedestrian and car. Then the time difference between the time pedestrian leaves the conflict zone and the car arrives on that zone is registered as a PET. But the whole idea behind measuring PET is when we put all this information together to generate a heat map of the intersection. So our safety analysis engine stores all the PET values based on their timestamp, type of turning movement, the class of the object involved in that conflict. Then the user can visualize that information in our dashboard using interactive heat map with filtering option based on the type of road users, turning movement, to get more details about the root cause of the conflict and safety issue at the intersection. Then the user can proactively identify the risk of intersection and plan to solve the safety issues. Just as the last slide, I want to focus a little bit on the 5G technology. So What we see because of the reliability of the LiDAR technology, our perception software, our open API, and 5G technology opens up different opportunities that we don't see in a typical traffic monitoring use cases, such as sharing pedestrian data with connected vehicles. I think this is a great value that 5G technology, LiDAR, and our AI can bring to the community, which helps to improve the safety of the road users, especially when it comes to the low lighting conditions, snow and rain, or detecting pedestrian and crosswalk, especially in area with high elderly population, and improving accessibility for all users, and potentially using this technology for incident detection and emergency dispatching. These are the case studies that we're working with university partners and Rogers in Canada. And this was a quick overview about the technology, and I think we can now take the questions.
Perfect. Thanks, Asad. Wonderful. Well, thanks, Neel and Asad. And I think we've got I've got a good amount of time to have a little discussion here. I think, with respect to let's just start with Kelowna. I mean, what are some of the learnings or use cases you're pursuing with those deployments, and how has the city been able to leverage that type of information?
Yeah, I mean, I'll answer that. So, it sort of started with the discussion with them in terms of identifying what their problem statement was, and they highlighted to us, and I think that was a really interesting way for us to approach it. But they identified that there was some safety concerns within a couple of intersections in that sort of key district. And so, from our perspective, we knew that 5G in theory could help solve for that, but we really didn't know what the overlying technology was going to be on top of the 5G network. And so that's where, through some of the research, we'd engaged with Asad and the team, and we'd started to really familiarize ourselves with the benefits of LiDAR. And John, you kind of mentioned this in your intro, but Canada has harsh conditions, and so we were a little bit reluctant to sort of go down the path of a camera, a video-based technology, knowing that there's still lots of development that's happening in the AI space to ensure that the object detection and identification capabilities are fully developed. But we had a lot of more confidence around LiDAR in that. And so I think that was really kind of eye-opening for the municipality to be able to see, how these intersections could be represented in a 3D way rather than in sort of the traditional 2D manner, where really you're putting a whole bunch of, I guess you're sort of throwing your safety into the efficacy of a particular AI algorithm in a way that, we don't think that the market is mature enough around yet. Do you want to add something to that, Asad?
No, I think from our perspective, there are for the Kelowna, there are a couple of things that was really interesting for us. I mean, definitely like solving the problem that the community is facing is one aspect. But from our perspective, I think what we see as a potential of 5G, 5G is really interesting technology, but we're not like what we see as a potential of 5G is down the road when we need to really have the infrastructure to be able to share massive amount of data in a low latency with other objects. I think the greatest portion of the technology that we are building is the capability of sharing data with connected vehicles down the road, and having I think I see the near future to have like connected vehicles. They are all connected to the 5G with a simple SIM card and 5G modem, so then we can easily share this information. I think that was the greatest value that we saw in this project, and we were interested to be involved.
Yeah. And I mean, the near misses piece, I think, is delivering, is going to be a really, really important feature for both, Kelowna, but we've already started getting inbound from other municipalities saying like, hey, how can you help us? Because we have some really problematic intersections. and we really need help on it identifying how to replan around some of those. And you don't want to have to wait for after the fact, and so I think that's what's really important here, is that there's a preventative opportunity that will help municipalities get to that Vision Zero objective that they have.
Yeah, and I guess along those lines, how are with your focus being in Canada, how are municipalities thinking about being able to kind of get to that Vision Zero? In terms of timing to roll all this technology out requires a lot of investment, a lot of time. What does the roadmap look like?
Yeah, I mean, it's actually been quite interesting, because when we sort of started our journey with Asad and the team, it was pre-pandemic, and the sort of the composition of the traffic environment was very different than it is today. In fact, I rode my bike today after a while. It was a sunny day here in Toronto, which is causing all the backdrop. But it was really kind of eye-opening, because I haven't rode my bike into the office for a long time, and there was really no cars on the road. And so I think, what's interesting is this is giving us a really interesting opportunity and time to be able to test a bunch of different things, because as, again, the world starts to open up, all of these issues are going to start to creep up and become more evident again. And, there's going to be that renewed intense focus on making sure that as people think about different modes of transportation, maybe outside of their car, but into more vulnerable modes of transportation, the need for this safety is going to be elevated. So I think, the municipalities who are future oriented are already starting to come to us, but we know that, let's say in a few months from now, it's going to be the hot topic, and it's going to be something that everybody is asking for. So, I think we're pretty excited about the progress that we've been able to make, and sort of the response that we've been able to provide to some of these municipalities.
That's great. How about, let's see, switching gears a little bit, I guess back to kind of the data that is over 5G. I know, Asad, you do some local processing of the LiDAR data, but also communicate some data as well up to the cloud for your platform that you share. Can you talk a little bit about kind of the role of 5G wireless communication in your type of application?
Yeah, sure. So eventually what we're exploring right now is, instead of having edge computer at each, even though it's a small edge computing unit, but still, instead of having edge computer at each intersection, we might do some pre-processing using a simple low-cost CPU to reduce the amount of LiDAR data, pack it, and then send it to some sort of still local but centralized processing unit, which is basically, it's going to be a local, let's say, data center or something like that, which covers multiple intersection. So this is one of the areas that we're exploring. But I think from our perspective, the greatest value that we see is being able to use the 5G low latency and share the data with connected vehicles down the road. So we do real-time process. We get data every about 10 to 50 millisecond. We get the LiDAR frame processed, and then if we can have a low latency network, so then we can share this information to be able to comply with the low latency requirement of sending the data to connected vehicles. I think that those are the two main aspects that we see with respect to the 5G.
Mm-hmm. And obviously, I guess that would also help maybe reduce some of the costs associated. How does the cost of these LiDAR systems that you're putting out there compare to say other types of sensor technologies?
Yeah, so far it's with respect to the price, the solution that we are providing, including the edge processor, the software, and the LiDAR, is really competitive with existing technologies. But something that is really important is not just the cost of the whole equipment, it's more on the installation side, the cost of the installation, just giving you an example, if you use radar, you need to put 4 radar, one one for each approach, which means that you need to bring wire underground to the pole that you have traffic cabinet to be able to connect this, your sensor to the traffic controller, for example. So with LiDAR, if you use single LiDAR, so we literally use the same pole. So there's no wiring, there is no like high cost maintenance requirement. So that's, I think, the winning factor of the LiDAR with respect to the other solution, with respect to the, let's say, integration and installation cost.
Yeah, that's great. And
sorry, John, I was going to add. Like, and cost is definitely a factor.
Yeah.
But I mean, I think it's been really kind of interesting to see the costs come down on LiDAR as well. You know, there was a time I remember when we first used to hear about LiDAR, and you know, how would that ever be deployed at scale? But now, like, you know, with the pucks, et cetera, that you guys have, the costs have gone down dramatically. And that's going to be really, really important because we know that cities are going to be cash strapped. And we're going to have to think of some really innovative models, commercial models, to be able to make sure that we get these deployed across all these municipalities. And so, you know, it's good to see the trend in terms of the cost coming down quite dramatically on LiDAR. But definitely there's going to have to be some unique considerations in terms of how we then deploy these at scale in municipalities.
Yeah, it's an interesting point. You know, certainly the cost coming down, but also I would imagine cities, you know, there's so many different types of technologies and sensors out there that you could have a light pole that's just littered with all this different technology. Maybe to have a single sensor is helpful just from a aesthetic point of view, less equipment out there. And maybe it goes back to your point earlier, Neel, about, you know, privacy. You know, how do your customers think about that? Is there conversations within the government around how to regulate and control the use of facial recognition technology, or where's it at in Canada today?
No, I mean, we're very sensitive to it here. We're very privacy oriented as a country. I mean, it's not news in terms of some of the activities that, you know, the Alphabet company Sidewalk Labs, you know, was associated with. So that we're very privacy oriented, and as Rogers, you know, that's always been part of our DNA and our nature, because we're a regulated organization, but we hold customer data, you know, on an everyday basis. So privacy is something that we've always been oriented towards. And I think, again, that goes back to why we were attracted to LiDAR over other technologies. And I think that that's helped the conversation quite a bit in terms of having these discussions with municipalities, because I don't have to explain to them what de-identifying is, and not to say they're not sophisticated or they don't understand some of the technologies, but their constituents, you know, are the ones that they need to be able to explain it to. And all we have to do with LiDAR is, and this is what we've done, is we've just showed them the images. Like, this is what we're capturing. And, you know, it goes back to, you know, a picture is worth 1,000 words. Well, LiDAR image is worth, like, you know, a lot of scrutiny and sort of, you know, back and forth in terms of having that dialogue. So that's actually been really helpful from a change management perspective, I'd say. And again, another reason why we're fairly bullish on the technology.
That's great. Well, good. Well, we've got a few minutes. We've got a few questions from the audience. One here from Austin Wilson. Hey, I know Austin. How you doing, buddy? It is what is the overall sentiment of LiDAR technology for roadside safety from cities with 500,000 population and below? So yeah, it's interesting. You know, how do big cities think about Vision Zero and these types of technologies versus smaller cities? And is there the same interest in analytics and smart technology?
Yeah, I mean, sorry, go ahead. Yeah,
no, go ahead.
Yeah, I'll just say, like, we're collaborating right now on an initiative. It was just sort of publicly announced yesterday, called the Future of Cities, with our partner Communitech, and we've got, you know, a couple of municipalities in there, and so we're working with everything from, you know, many hundreds thousands of people in the community, in cities like Brampton to smaller municipalities like Kelowna, which is about 150,000, and the challenges are the same. From that perspective, is they need to be able to protect their citizens from, you know, distracted driving or other challenges that we're starting to see with, you know, additional logistics companies being out on the road. They want to make sure that there's the right protection for the people that are going to be using those roads. And so I don't think that the applicability of this technology varies much from the size of the municipality as at all.
Yeah, I agree on that point. So yeah, so even for the small municipalities, still most of the cities they are promoting biking, walking as new modes of the transportation. So still, like, the safety issues will happen in even like small communities, and that's where like the technology can help.
Fantastic. Well, you know, we're running over on time. I could talk with you guys all day. This has been a wonderful conversation, and I certainly appreciate your time and your partnership. And you know, we're excited about the future to continue to work together. And so, please, if anybody out there in the audience has any more questions, you know, please send us an email, and we'll definitely can touch base offline. So I'll hand it back to Pam to close things out. And thanks again, everybody.
Thank you.
Thank you.
Great. Thanks so much for joining us today, John. And thanks again to our guests, Asad Lesani and Neel Dayal. We are unfortunately out of time. And if we didn't get to your question, no problem, because you have everyone's contact information right there on your screen. So you can reach out directly with questions about Bluecity technology, smart city solutions, or the role of 5G or LiDAR in those smart cities. Again, this webinar will be available to view on Velodyne Lidar's YouTube channel. I want to thank our audience for watching today as well. And if you're interested in learning more about the latest developments and applications in the mobility industry, please be sure to join us on April 23rd, when we'll be talking to Atul Acharya, the Autonomous Vehicle Strategy and Operations Director at GoMentum Station. Owned and operated by AAA Northern California, GoMentum Station is the nation's largest dedicated secure testing facility for connected and automated vehicle technology. And one final item to mention here, Velodyne Lidar Live will be on hiatus for the month of March, and that's because we're gearing up for our virtual spring summit taking place on March 25th. Be sure to join us for this free virtual event called Disruptive Women Powering Our Autonomous Future. This half-day summit will examine the role of female engineers and executives in the mobility industry, as well as conversations about current AV technology and the direction we see it moving into for the future. Featured speakers include Congresswoman Debbie Dingell from Michigan and Laura Major, the CTO of Motional. And some of our summit partners include Zoox, NVIDIA, Toyota, Volkswagen, PAVE, and SAE. So you can register for free at velodynelidar.com. Thank you again for joining us today, and we hope to see you there on March 25th.